One o'clock class, different class to make. Any class. He did actually a really good job today. I feel like it was a difficult concept, honestly. I like when you write down that thing. I was thinking about this was well done. That's so cool. I don't even know who's asking questions, but it was funny, like my big data. I can get correct. I'm like, I don't understand. It's not what I understand. Oh. I really felt like cats and then getting to this second one. I guess it's good to put it like release.
So I have a proposition. I think we close the back door. I get distracted when people are walking through it. It gets too hot. If it gets too hot, maybe we'll stop and reopen the door. Does that sound okay? Okay. The other question I had for you, do we like two projectors or one better? How many, hands up for one? Hands up for two? Okay. Well, nice to see everyone. Happy Thursday. We are wrapping up the week. We have a somewhat big one for today. We're probably not going to take all of class time. I think we're going to get out a few minutes early. At least that's what I'm anticipating. And then you owe me some time if we do. Sound okay? I'll take that as a yes. How's everyone doing? We left off last time talking about panel data. We're going to fully close the loop on panel data. We're going to walk through a couple of examples. I left you with a big question, or like a medium-sized question, about visualizing a certain kind of, visualizing panel data for a certain kind of question. So we're going to get through all of that. We'll talk about the new tool, and then we'll talk about, we'll get through the exercise and then wrap up part one. So that's where we're going today. A couple of housekeeping items. We have exercise 1.5 for class today. We have homework 1.4 and 1.5. So both kinds of panel data we talked about this week. Homework 1.5 is very short. It's like one question. It really should not take you that much time. But that's there for you. A little bit of extra practice. All right, and then mini exam on Tuesday. So that's our first one. We'll spend some time at the beginning, so 20 minutes, the beginning of class. It's open book, open note. So that means you can bring whatever you want into the exam, anything on hard copy, just nothing electronic, unless I like pre-clear it and we have a conversation about it. So yeah, a lot of people bring in like a note sheet. That's what I would recommend. And it's essentially going to cover the kinds of things we've been doing all semester. There's no Python coding. You'll have to think about like visualizations and such, but I won't actually have you write out Python code. Okay, any questions about that, Casey?
What about chart formation like with Excel and Sheets?
So none of that. I could have you write out like a visualization you use, but I wouldn't have you like write down, this is how I would do it in a specific software. Yeah. We'll save that for the homework. Any other questions? All right, and then I'm gonna send out more information when I post the mini exam demo. So that'll get updated. I'll send out a new one reflecting what we've done this semester. But feel free to take a look at the one from last semester if you'd like. Okay, so we ready to finish talking about panel data? Resounding yes. Nice to hear it. Love the enthusiasm. So this is where we started with part 1.5 last class. Essentially, we've been talking about long format panel data. There's a bit of intricacy here with our panel data structure, right? The core idea with panel data, my favorite data structure, is we track both across individuals through time. So we have many individuals and many points in time. We talked about long format panel data, which look like this. So we have, a bunch of countries and then a bunch of years, and we record coffee consumption per capita just as its own variable. The basic idea was sometimes we have questions like this. So here's our data set, here's our question. Are countries drinking more coffee in 2019 than in 1999? And we sat down and thought about how we would visualize the data for this question. So how do we summarize in the most effective way? And we thought about a couple of different ways of approaching this. One of them, I didn't have this in the slides last time, but this is one way of visualizing long format panel data. We can just take the data series, so each time series for each individual country, and just plot that as a multi-line graph. We've dealt with multi-line graphs. I think someone in class, I forget who it was, proposed this as a way of visualizing the answer to our question. So I just wanted to put it in the slides. What do you all think of this? Are countries drinking more coffee today than they were in 1999?
It's really hard to tell because just looking at the bottom, there's a lot of colors that look really similar, so it's kind of hard to tell which ones are actually going up, which ones are going down. Is that one that really spikes up?
Yeah.
All the other ones kind of get jumped around.
Right. So Ryan's saying there's this one that spikes up, and I didn't do the research to figure out which country that is. Probably Soviet bloc. That's happening in the 90s. And then there's a lot of variation going on for the countries that are lower coffee consumption per capita. And so it's hard to kind of tell. What else do we see here? That's the main point. This is hard to read. If I'm asking what's the time series for a particular country, I would plot that as a line. But if I'm asking, is coffee consumption per capita different between two different years across countries? This is not the right figure for it. You can show it. You can show the data exactly. But when we're constructing figures, we want something better than that. We want a way of communicating an answer to our question. So here, I would say this is not an effective figure for our question. I look at this, I don't know if countries are consuming more coffee per capita than they were in 1999. I know one is, and looks like maybe a few others, but beyond that, I'm not sure. The other thing we talked about was to use a histogram. So this is another tool we've already developed. We have coffee consumption per capita and its distribution in 1999, and then we compared it to the second year. And this was our overlaid histogram. We used transparency to sort of show one histogram on top of the other. And we said, this is not great. It's better than when we had 3 colors, but it's still not that great at communicating changes in distribution through time. We said maybe there's some outliers here, but still not so great. So we turned to a multi-box plot, and this is where we spent, I think this is most of what we did for wide format panel data last class. So we talked about, is the world drinking more coffee? Well, here, using 2 box plots for the 2 years we're comparing, we can then look at the specific quartiles and how they've moved between the 2 years. And this is much easier to answer questions about changes in distribution. Okay, so it looks like the world is drinking more coffee. This is all still in long format panel data. So we broke this out into 5-year increments instead of just a 2-decade jump. And this allowed us to ask some more focused questions. I think we didn't do this last time.
We didn't ask the questions.
I showed you the figures, but we didn't ask the questions. Do you want to spend some time with these questions? So what about this one? Which years show at least half countries consuming less than 5 kilograms per capita? I know you probably are thinking through an answer in your head. You have something fun planned for the weekend, probably, I hope. And I hope it's not studying for my mini exam. I know all of you are just like super excited to study for the mini exam. But I hope you have something else fun planned too. So tell someone the something fun that you're going to do this weekend, and then tell them an answer. And when I say answer, I mean not just a number, but also the process that you arrive at the number.
So, I think 2001. That's like what I thought. It was Jagger. Yes. Got like 6 months already. Yeah, and then like yes.
February 25. No one's ever called us, but I hope no one ever does.
No, I'm gonna say
Okay. We have a lot to do today. I'd love, if you want to keep chatting, maybe turn the volume down. Feel free to. I have a bunch of questions for you, so you'll talk to each other. Someone want to help me out here?
Oh, no,
DK.
2019 and 2014 offset.
2019 and 2014. So which years show at least half consuming less than 5 kilograms per capita? And so maybe we reverse it.
Yes.
Okay, so just the lower ones. And how did we find that?
I looked at the median for, the medians for each one of them,
Okay.
and which one was lower than 5.
So which one was the
1999, 2004, and 2009.
Nice. So we looked at the medians. We're thinking about half, and then we're just comparing that to 5. So I just highlighted the medians, and then we compare it to 5. Any questions here? You want to do some more of these? What about this one? Which years saw the largest jump in the medians? So this may be easier. 15 seconds, and say it to your neighbor.
I don't see them all. I don't see any of them having a the largest jump in the millions is between 9 and 2000.
Okay. Someone want to help me out here? Where did we see the largest jump? Yeah. Nice. So these two. It's maybe a little hard to see, but yeah, I would say those 2 years. I'm sorry. Remind me of your name. Bridget. Okay, so Bridget is saying we're just going to look at the medians and then look at the difference between any 2 years, and here we see the biggest change. Yeah, Erwin.
If it's the difference between any 2 years, would it be 2009 and 2019?
Oh, technicality. This is good. Yeah. So the way the question is worded, I think you'll be right. So, so yeah, going from you said
2009.
2009 to 2019. Yeah. So these would be bigger than these two. So yeah, if we were just asking every pairwise comparison, Erwin is saying that would be the biggest jump. My intention for the question was between anyone, sort of in sequence, but yeah. So yeah, good. Love that. Any questions here? So 10 lecture points for an ambiguous question. Thank you, I appreciate it. What about this one? Is the country with the lowest consumption consuming more today? This one could be a little more, this one could be ambiguous too. My intention with the question is the lowest in any given year. 20 seconds? Tell your neighbor.
So normally you want to do it now, in 1999.
I think usually the lowest in 1999. In 2019 well, yeah, he was like saying it could be ambiguous. No, I'm saying it's the lowest because so, but the thing is, even if it is the lowest in 1999, they still would be consuming. That's true. That's true.
Actually, so this is good. I guess actually each year, actually, they go up each year.
Yeah.
All right. Someone want to help me out here? Right.
Normally you wouldn't be able to tell, but because 1999 the minimum is further to the left than any of the other minimums, you know that it had to increase.
Okay, so we know the lowest coffee consumption per capita happens in 1999. And, like, that country has definitely increased their coffee consumption per capita. So that's one way of thinking about this question. And all we do is look at the minimum and then see what happens to the minimum. Has it changed? Any questions here? Any other variants on, I think this question is also a little ambiguous. Any other kinds of answers? When I wrote this question, I was thinking, how have the minimums changed? And I would say they're increasing. Okay. So what patterns do we observe about the maximums? This one is a much more open-ended question. I would say there's not clear patterns. We see decreasing consumption per capita for the maximum over the last 4 bars. But the first one sees a massive spike in the maximum. Okay, any questions? So as we go from here to here, it's very large, and then these are basically downward sloping. What about this one? I think this will be the last one. There are a couple parts to it, so let's take a minute. Tell your neighbor an answer that's clearly wrong.
The answer is the
All of them.
Okay, someone want to help me out here? I'm not just looking for an answer, I'm looking for a process. How do you find the answer? James.
in our program, we said all of them.
Okay.
And when we pay attention to them, well, first, the first 3, there you can clearly see that 50% of the data is behind 5 kilograms per capita.
Okay.
And in the second, the last 2, 2014 and 2019 of the data, even though 50% is above 5 kilograms, it's very much significantly inwards, closer to 50% than it is to 25%. Which
Okay.
would indicate that more than 25% consume less than 5 kilograms per capita.
Okay, so we're sort of using this idea of minimums for some of them, but then also thinking about the 25th percentile and whether it's below 5. Yeah, so this is the process I would follow too. I would just look at the 25th percentile, so the Q1, and then compare that to the 5 kilogram. So if the 25th percentile is below 5 kilograms per capita, then we know more than 25% would consume less than 5 kilograms. So it turns out to be all of them. Any questions here? Nice job. So this is sort of how we use these multi-box plots in panel data to make comparisons. We could ask some other questions. So like thinking about the range, which one has the largest difference between the maximum and minimum? What about this question? And this is closer to where we left things last class. I want you to turn to your neighbor and propose how you would think about answering this question. In which year did most countries increase their coffee consumption? Take maybe 2 minutes here.
was thinking the average is still up.
2009, 2014.
Yeah.
But
You're right.
that's where the 50% maybe is going to significant.
Also, it has like high increases. Okay, yeah. Yeah. But what about 2019?
Yeah, but I think in which years, you're asking which year ago was country increase for I think it's 2009 did the biggest jump up, whereas 2018 is that's not a big jump.
Okay. I'm looking for ideas here. Not necessarily correct answers, but how are we thinking about this figure in relationship to the question? Please.
Oh. Okay, I understand what you're saying now.
Someone else.
Alright, never mind.
Right.
What I was thinking was, you want to look where the biggest movement happens, and I was thinking the biggest movement was 2009 and 2014, because the
Okay.
median moved up the highest.
So we see the biggest change in the median happens between 2009 and 2014.
Yeah.
Erwin.
Looking at the IQRs, you see when that shifted, because that shifted when 75% of countries increase their consumption rate.
So yeah, looking at the quartiles and maybe the movement of the boxes, whether that's moved around, and which year that moved the most. So that's maybe another idea. What else? Can I propose something? What if we saw every one of the 5 quartiles move up, but every other country moved down? So I've increased the coffee consumption per capita of 5 countries, and I've decreased the coffee consumption per capita of all of the rest. So we've 34 countries, 5 of them have increased, and 29 of them have decreased. And yet we would see a shift up in all of the quartiles of the box plot. But most of them would decrease. James.
You say you would, if that were to happen, you would see a shift up in all the quartiles?
Yeah.
Even the median?
So yeah,
Median
let's say we move the country at the median, we move them up a little bit.
But then I just create a new median? Because
Um,
that's not happening in the data.
Well, yeah. So if we moved the median up with, before it hits the next one, the median would go up. Yeah. Right.
If that were the case, maybe we could make a different graph that shows like the difference in consumption between years, like subtract the two. And if it's mostly negative, you know that most countries decrease. If it's mostly positive, you know they increase.
So Ryan's proposing an alternative visualization for this data to allow us to see something that we cannot see in this data visualization. I can't tell whether most countries have increased or decreased. And fundamentally, the reason is because I can't track countries between bars, or between box plots. All I see are the quartiles, and I see some scatter with the strip plot, but I don't see how that individual tracks between strip plots. So with this visualization, I cannot answer the question at hand. I don't know how many countries are increasing or decreasing. What about this question? How many countries increase their coffee consumption between these 2 years? Same question, just framed slightly differently. And again, the fundamental problem is present here as well. I can't track an individual country and its coffee consumption through time. That's not visible with this visualization. So sometimes our data visualizations are ineffective, but they still communicate the data. In this case, the data is not communicated for our question, even at all. So we could zoom in, we could sort of check what's going on. Here it definitely looks like most countries are increasing their coffee consumption in between these 2 years. And there probably is a way of just checking this visually. Like you could go through and check something about the medians and like whether more are consuming more in the second year. But we have a much better approach. Like we don't have to like walk through this morass. I can show you a way out. The core fundamental problem we've just run into is that we want to make the comparison within a particular country between the 2 years, right? It's that difference we care about. And what we weren't able to do with the bar chart, the box plot, is to show this. It turns out to be very challenging in long format, which is precisely why I've introduced this sort of headache. We've spread the data out across different rows. So we'd have to compare one row to a different row. But like we talked about last time with panel data, we actually have a much simpler format for making cross-year comparisons. So instead of thinking about data as each row representing one entity at a point in time, and then we keep track of the data, here we're representing each row as an entity. And then each column is keeping track of the unit of observation through time. So we have sort of the T index is across the top. And then, so all we have to do to make the comparisons we're interested in, so how have countries increased or decreased their coffee consumption per capita, all we have to do is compare two columns. So now I'm just asking, is this different from this? And that's something code can do very nicely for us. Or really, not just even code. It's just the data allows us to answer this question much more readily. Okay, so here's the wide format, and then this was the long format from last time. So we had country code, but countries show up many times. Fundamentally, wide format and long format are the same data, so you're not losing anything by switching between the two. They're exactly the same, just organized differently. So this is where I am looking for you to try to construct a figure that can visualize what we're interested in. We have wide format panel data, and we're thinking about how to construct a visualization to summarize the data in a way that allows us to answer this question. Brian's already given us one shot. I want you to turn to someone next to you, think through how, what is it that we want to do, and how would we construct a data visualization to do it? My last class, I asked the same question of. We spent 2 minutes on this. No one had an answer, or there was sort of an answer, but I think y'all can do better.
That's not ridiculous.
What if you just put it in one?
That's not ridiculous. Or I feel like that's not ridiculous. That's not a bad idea. I was thinking something like that.
All right. I've been listening. I've heard some correct answers, or some. In some ways, there are correct answers, but there are multiple ways of doing this. I've heard some good ideas. How might we create a visualization to show an answer to this question? Yeah, Jackson?
Yeah. Okay, this maybe is possible. I don't know. What about like a scatter plot? It's like one graph for 1999 and 2019.
Okay.
And it's like a scatter plot side by side.
Okay. And say more about the scatter plot?
Each country is represented by its own dot.
Okay.
Color coded. I don't know.
Yeah. So Jackson's saying, look, we're gonna take. We have two columns, maybe the base year, so the first year on the horizontal axis, 1999. We find the coffee consumption per capita for every country in that 1 year. We plot that on the horizontal. And then on the vertical axis, we take the second year, so the 2019. And we find a position on the two dimensions that corresponds to the coffee consumption per capita in both of the years. Any other ideas? James?
I might be describing it wrong, but what's it called when you have a histogram like shape filled with dots?
Oh yeah, it's like a violin plot.
Mm-hmm. Yeah,
There are a couple ways of doing
yeah,
that.
something like that. Could you potentially, similar to what he was describing, could you potentially show something like that, but then overlay the data one on top of the other, and then color coded one for 1999, one for 2019?
Maybe. I'm not entirely sure I follow.
It's like, it's like.
Maybe we'll chat about it after class.
Yeah, maybe.
Yeah, Tanique.
You could use a bar plot, where you plot 1999 for country A and then 2019 for country A. But if you have like tons of countries, it's really
Yeah.
fun.
Yeah, so we could definitely do that for one country. And then I think the challenge would be looking at it systematically.
Yeah.
Yeah. Yeah,
Are
BJ.
we not going to be coding this?
We are.
Okay, so I was thinking like do like years on top and like countries on the sideways, and
Okay.
then do 1999 and 2019, and then just do like minus that, and then add a new column, put like the numbers, and if it's positive, then it's increasing. If it's negative, it's decreasing, and then
Nice.
do count for the positiveness.
So BJ's recommending we take a difference between 1 year versus the other, find a new column, call it change, and then we could create a histogram of the changes and see how many are increasing, how many are decreasing. Great idea. I don't have that in the slides yet. We'll do something like that in the exercise. Okay, lots of good ideas. There are lots of ways of doing this. I think Jackson's idea of the scatter plot is in the top tier of data visualizations. I think this is a great way of showing changes through time. So I have 2 years, just as Jackson laid out, horizontal axis, 1999. We encode the horizontal position as the coffee consumption per capita for that country in 1999. And then on the vertical axis, we have coffee consumption per capita in 2019. This gives us 2 coordinates, our x and our y, because we have 2 coffee consumptions per capita in 2 different years. And then we plot each country as a separate point. And this allows us to think systematically about what's happening to coffee consumption per capita as it changes through time. So let me just walk you through one, and then I'm going to ask you, how would you find the countries that are increasing their coffee consumption per capita? So for example, I have this country here. I don't actually know which one this is. Yeah, I'm not sure. But this is, on the horizontal axis, it's slightly below 12 kilograms per capita. So like 11 kilograms per capita in 1999. Then in 2019, it increases to roughly 15 kilograms per capita. So just that one point has encoded two values. Just like we do with x and y coordinates, here a scatter plot is just encoding points, but 2 dimensions of data. All right, so my question to you is, how would you go about systematically finding the countries that have increased their coffee consumption per capita between these 2 years? Maybe chat about it with your neighbor, 30 to a minute, and we'll come back together and you give me an answer.
Basically, you could draw a line, bigger the line, bigger the
steeper the slope, all of them have a bottom. The steeper the slope, the bigger the change.
I don't know.
So you got draw like a trend line. It's not based off the points you got ranges.
Yeah. Like you just do 4, 4, 8, 8.
Yeah, literally, because the slope gotta be exact one. That will show you what's above one and what's below.
All right, someone want to help me out? How do we find this, Casey?
Draw a line on the slope of one, and then you see the points that are above the slope. That means they're increased. And
Okay.
the points below the slope means they decrease.
Okay. So Casey's drawing a line along the 45-degree line. So going from 0, 0 to 24, 24. And everything above the line, we see the second year has a higher coffee consumption per capita than the first one. So if it's above the line, it's increased, and if it's below the line, it's decreased. If you ever get stuck how to interpret these kinds of things, just use one point, for example. So this one, we see coffee consumption per capita before is 11, and after is about 15. And it's above the line. So we know that coffee consumption per capita has increased. Everything above the line has increased, everything below the line has decreased. Any questions here? Okay, nice. So I just have some nice little visualizations of this. Here's my 45-degree line. We'll do this together in a second. You'll write this in code. If we're above the line, we increase, and if we're below the line, we decrease. And then if we wish, we can add colors to just separate these things. We're not going to do that in code. You can if you like, but you'll want to create some scatter plots? This is the I think top tier of figure types. We're going to spend more time in part 2 talking about scatter plots. They are simple, not fancy, and very effective. Okay, so y'all want to hop on over to the course page. If you don't have the course page pinned in your browser at this point, what are you even doing? I've given you automatic, what's the word? You don't have to log into Duo Mobile, ever, for this class.
Will you be uploading the recording before printing?
I can, yeah.
Okay. My computer's just dead. I forgot my charger at home. So.
Oh, yeah.
And I won't be able, I could write it all in my notes after I know, but.
Yeah. The code is also in the slides.
Oh, okay.
So I'm just going to load the notebook. So if I click on this for exercise 1.5, it loads in my browser. What's the first thing I do? Casey says save. Someone else tell me, what's the first thing I do? Save a copy. Remind me of your name, is it Kai? Kai. Kai's saying save a copy. So Casey and Kai are both saying save a copy. Someone else want to tell me what to do next? Oh, Taylor, yeah. I say save a copy. Okay, save a copy in Drive. And when I click save a copy in Drive, it opens a new one, but it's now in my drive. I'm going to save it. I've now changed it so that if you try to run this without saving, it gives you this error. It's not authored by Google. Sounds scary. I authored it, so it's okay, but save a copy. All right. So first thing we'll do is just run our imports. And then we have our file path. And then I'm just going to load the data. So here I have our coffee per capita in wide format. And here I don't just have every 5 years, I actually have every year coffee consumption per capita for all of these years. What we're going to do is create a scatter plot of 2 different years. Should we use different years than this? What if we do 1990 to 2000? You can do that instead? Okay, so we want to create a scatter plot. You've started to develop some intuition for how to work with Seaborn. We're going to take 2 minutes here. I want you to try to write out, without looking at the slides, write out how to create a scatter plot looking at the change in coffee consumption per capita between 2 years. We can use the original years. My code will run between 1990 and 2000. And then once you get your figure, show it to someone else. If someone shows you a figure, then you say, you're excellent at writing code. That's the correct response. Take about 2 minutes here.
I don't like how you put it.
Yeah. Not live. You'll have to wait 10 hours to talk about
There won't be a world where I'll be
Like that. Now I can just look at this guy. This is good. That's fine.
Yeah, we'll try to use access sales. Okay, how many of you got a scatter plot? Okay, that's pretty good. If you didn't, you're also in good company, so we're going to walk through this together. Someone who got this. Someone want to help me out? How would I write this code? Starting to become more familiar with the syntax of Seaborn. Yeah.
SNS.scatterplot.
SNS.scatterplot. Okay.
And then
Per cap.
X equals 1990.
X equals 1990.
And
Y equals 2000. Okay. And then if we run this, we get a scatter plot. Any questions here? So this is very similar to all of the other figures we've created in Seaborn. SNS dot, and then you have the figure type. You enter the data. You enter X is equal to the column that you're interested in on the horizontal axis. And then if you need a vertical axis, you can specify that too. Jackson?
How can you make the X and Y axes the same?
Yeah, so Jackson's question is related to my next question for you. Does this look like coffee consumption per capita has increased or decreased? Decreased. And why does it look like it has decreased? So you draw a line between here and here, and you see that most countries are below it. Just like with different sized histograms, we can communicate lies. Like we can mislead with our figures. This figure is misleading. Yeah, Tanish?
Oh, I was just gonna say why it's misleading.
What's that?
I was just gonna say why it's misleading.
Why is it misleading?
Yeah, it's just because it's going up by increments of 2.5, or y is going up by increments of 2.5, whereas the x is just incrementing by 2.
So the axes are different. Where if we look back to my original figure in the slides, the axes were the same. So the increments are the same on both dimensions. And this is Jackson's question. How do we fix this problem? This is, I think, a little misleading. It makes it look like coffee consumption per capita has not been increasing when in fact it has. And the way to fix this is by changing the axis limits. So what we're gonna do next is change the axis limits. The first thing to do, well, you can know some code if you like, or you can write with Gemini. This is one of those cases where I think this is enough in the weeds that and it's pretty simple to do, that I may recommend you use Gemini in these kinds of cases. But I'm going to talk you through how to think about how to do this. Here, this is a default figure from Seaborn. The way I would write this in 2026 is to say, make the axis limits go from 0 to 24. So I've just added some comments, and Gemini reads this, and then when I enter a new row, a new line, it will auto-complete it for me. So Gemini's pretty good at these small things. Don't ask it to do big things, and also recognize that it can make mistakes. So I'm gonna hit tab through. And if I run this, I get a figure that has the same axis on both the X and the Y. Okay, so, but I wanna talk you through what this is doing. This is PLT. So just like, I'm still impressed someone emailed me saying, hi Tay-Tay, as the opener. But just like my friends in college called me Tay-Tay, we're calling matplotlib PLT. So we're calling matplotlib PLT, which is just a way that we modify the default Seaborn package. So we're saying, take this Seaborn package and then change the X limit. Here I'm saying an X limit going from 0 is the minimum to 24 as the maximum. And then I'm going to do the same thing for the Y limit. So Y going from 0 to 24. If we were to change this to 50, we can just change the size on the vertical axis, but we actually just want 24. You could put 25, just make sure they're the same. Ryan?
Because there's so many in 1990 that have 0 consumption, is it bad practice to make like X and Y -1 instead of 0? That way it's like more clear instead of being like half
Oh.
difference?
Yeah, so this particular year we've used, I guess a lot are at 0. So sometimes you can sort of back off of 0 just to show what's going on at 0. It's fine. It's probably better, not necessarily deceiving. Yeah, James?
I don't know what's new, but my code is coming up. I have the exact same code, it's coming up like more of a straight line. Yours is more spread out.
Interesting. So if you put the same year in both times, it'll look like this.
Well, no. Okay, I see what the problem is. I have 1999, you have 1990.
Oh, yeah. So if it's 1999, if the 2 years are close to each other, then there's not going to be a lot of spread.
Okay.
Yeah. Any other questions? So this is maybe what you're getting. Okay, so this is a pretty good figure. We can add a title if we like. So we could say plt.title, and then this is changes in coffee consumption per capita.
So why is X not 1999 and why not 2024 or 2019? Sorry.
Oh, we can do that one too. I was just changing the base year, but maybe that's confusing. So this will perfectly replicate what's in the slides if you change the years. Okay, any questions here? So you can use this for the exercise for today on Gradescope. So this is, you can just right click Save As, and this will download into your Downloads folder. All right, should we do some other things? Y'all want to add a 45-degree line? How would we add a 45-degree line? Comment, add a 45-degree line. Personally, I never remember how to do these things. And so I either check with an AI or I check by Googling the question. This is historically, when writing code, we usually go to Google. But in the last 3 years, we've started doing it this way. So I add a 45-degree line, and then I open a new line, and it writes this. It made a mistake by adding PLT again underneath. So I'm just going to delete that. But it did pretty well. So I've added a 45-degree line. Any questions here? The other nice thing is when you create these figures and you save them, then you can always go back and use the same code again. So that's one of the benefits of running through many exercises like we do in class. I'm going to color this red. What? Oh, nice. All right. Gotcha. Nice. Okay. So this is a nice figure. So the last thing we're going to do today is talk about selecting. So we're going to go through and figure out which countries and then how many countries increase their copy consumption between any 2 years. So if you use 1990 versus 2000, feel free to use those years too. But I just want to talk you through what we're about to do. This is the last thing we'll do, and then I will send you on your merry way. So the last thing is we just want to count how many countries have increased or decreased. And one way we can do this is by creating a column of changes. I forget who brought this up. Someone brought up how to calculate changes. And that's one thing we can do. And in fact, we're going to do it in code in a second. So if I wanted to count up how many countries have increased their coffee consumption per capita, a first thing I would do is just calculate the change and figure out whether this was positive or negative. The second thing I would do is then try to figure out which countries had increased. And then the last thing I'd do is just count up how many rows were left. So this is how we're going to actually go through and calculate changes. I have all the code in the slides if you end up needing that. But I just want to talk through how we would do it in the notebook. You'll remember how to create a new column. So if I wanted to go row by row and find the difference between two values, all I have to do is say per cap, and then I'm going to define a new column called changes. And then I'm just going to take the difference between two columns. This turns out to be pretty challenging not challenging, but more steps in Excel. In Python, this is very simple. We have per cap, and then I want 2019, and then all I'm going to do is say subtract per cap 1999. And what this does is it goes row by row, constructing a new column called changes. That's the difference between 2019 and 1999. If I run this, it creates the new column. And let me just show you what this looks like. So this is per cap. We have changes. And then I just want to give you 1999 and 2019. And if we run this, we can see I have the changes column. I have the 2019 column. Sorry, the 1990, I can't speak. 1999, and then the 2019 column. And you can see coffee consumption for this first row has gone down. It's gone down from 8.43 to 7.92. So that's a decrease of about half a kilogram per capita. And we can see we've calculated that in the changes column. So this one line has gone through every row and constructed a new column that's doing the mathematical operation that we're defining. You're going to do something like this in your code, in your homework. It's not going to be this exact transformation, but this is the kind of thing you'll do. Any questions here? We could create a histogram. So we could say sns.histplot per cap and then changes. And here we could see a distribution of the changes in coffee consumption per capita across countries. So this would be a similar alternative to the scatter plot if we were interested in visualizing the changes. But I still think the scatter plot is better. We get to see exactly what the values are for the current coffee consumption per capita. Okay, and then the last thing is how do we count how many countries have increased or decreased? And this is where we introduce the idea of a filter. We're going to spend an entire class period on filters in part 2. I'm going to show you the first and most basic one. So what I'm going to do is try to select which countries have increased their coffee consumption per capita. So all I'm going to do is run a logical check, a logical condition. We're just going to check whether this particular row, per cap, changes. We just want to know if any given row is greater than 0. And as you'd expect, potentially at this point, this is going to run that logical check against every row. When we run this, it's going to get a list of 0 and 1. Sorry, true and false. So we're checking whether the change is greater than 0. So for the first row, it's negative. We know it decreased by about half a kilogram per capita. And you can see that shows up as false. For the second one, we found that it was increasing. So the values were positive, the changes were positive. So what we've done here is construct a list of true and false based on whether changes are positive or negative. If they're positive, it returns true. Now, the next thing we're going to do is just select only the rows that have returned true. And this, I think, is the most challenging conceptual or syntactic part of what we're doing. I'm just going to put this whole thing inside of some brackets. It's going to select only the columns that are the rows that are true, and it's going to remove the rows that are false. So I'm going to say per cap, and then I'm going to put all of what we just did, that list of true and false, inside these brackets. And when I run this, it excludes the first row and all of the other rows that see a decrease in coffee consumption per capita. And that's it. A bunch of little funny steps. It feels probably feels unfamiliar at this point, But as we start working with this more, you're going to get some experience with this in your homework. And then we're going to spend an entire class period covering filters because they're very important. So here's our list. These are all the countries that increased their copy consumption per capita between those 2 years. And we can see there are 24 of them. We could also get a length. So we just find the length of this thing. We can see that it's 24. But we could also just print it out and find how many rows there are. All right, any questions here? So at this point, how many of you would prefer visualizing data in Python to Excel? And how many of you prefer Excel to Python? Respectfully being an outlier, but I agree with most of you. I think visualizations are much easier in Python, particularly Seaborn. So this is the end of what we're doing in class today. Can I, just as like a recap going into our mini exam, can I show you sort of how I think about what we've just done? We're done with new stuff for today. What we did was talk about wide format, why we think it's valuable, and when to use it. We talked about multi-box plots, scatter plots with the 45, and then we did a little bit of filtering. Numerical data, panel and wide format, filtering, multi-box plots, scatter plot with a 45-degree line. But what the mini exam does is cover everything in part 1. Mini exam 1 covers part 1. And this is what we've done in part 1 so far. In 1.1, the variable we considered was categorical data. So the variable type was categorical. We did it in cross-section. The main operation we used was counting. So this is how we constructed our box plots. Bar plots. So we talked about bars and pi. Both are sweet treats. We generally talk about bar plots as, no one laughed, so I didn't say anything about it. We generally think of bar plots as being better in nearly every case than pie charts. Pie charts we can use in some cases. Most data visualization courses will teach you to never use pie charts. I think that's maybe a little too stark. Pie charts for binary categorical data can be fun. But generally default to bar charts. Then we talked about numerical data in cross-section. So we were also dealing with cross-sectional data. We talked about bins. So constructing bins and then counting in the bin. We talked about means, standard deviation, and quartiles using box plots. This was histogram and box plot. Those are main visualization types. Then we spent our part 1.3 talking about time series. We did sort of these data transformations. So you remember we constructed a new variable based on 2 existing variables. A lot like what we did today in class. We have row by row, constructing the real price from the nominal price and like a CPI conversion. And then we also talked about line plots and multi-box plots for seasonality. And then in parts 4, 1.4, and 1.5, we talked about long format panel data. We did a bit of grouping, not a lot, but a little bit. And then we talked about the multi-line plots and facets, which are pretty good. And then in 1.5, we talked about wide panel data. We did a bit of filtering just now. And our main visualization tool was the scatter plot, which is excellent. So this is sort of the structure. Be thinking about the kinds of questions I'm going to ask you. So this is like, can you diagram data so you know how to separate what you're seeing? Think about good visualization tools for the different data structures. And then also be thinking about how the visualization type matches the question at hand. So I'm probably going to ask you, here's a data set, here's a question, how would you summarize the data for this question? That's a very classic question on mini exam 1. There's a mini exam demo posted, feel free to take a look at that. It's a little bit different than what we're covering. but it's similar enough that I've left it up. I'll post an updated version maybe tomorrow, definitely over the weekend. Let's see. Any other questions before we take off? If you've done the work, you feel prepared. I've given you lots of chances to practice. That's on purpose. I don't want you coming into a mid-exam feeling unprepared. So study what you need. All right. So no code on the mini-exams, but I can ask you questions about visualization. I'm just not going to ask you to write any code. Okay, have a nice weekend. Office hours tomorrow. Drop by if you need.